In this video, we are going to see how to calculate work. So we have got a problem here in which we can see that the force is 50 Newton and the distance is 4 meter. It's asking us to calculate the work done. We write the formula Ft cosine theta. Now we have F and D, but the theta is missing. So if you look at the diagram, the force and the distance, they are in the same direction. That means theta will be equal to 0, which we can substitute in the formula. We get the answer as 200. Do not forget to put the unit, which is joules. Work done is 200 joules. Next, we have got a multiple choice. Here it says that the force is 10 Newton, the angle is 40 degrees, so theta is 40. It's asking us what is the distance moved. So its distance is missing, and it's telling us what's the work done, which is 50 joules. So we are going to substitute the numbers into the formula. So 50 equal 10 times d times cosine 40. Now d is missing, so when you use your calculator, you'll put d as x and use shift solve to get the answer as 6.52, and the unit is meter. Now let's look at some of the cases in which work done can be negative, 0 or positive. So if we have a box, let's say that it's moving to the right, it covers a distance d, then the friction will be always opposite to the motion, which we know. So the work done by the friction will always be negative. So when the force is opposite to the distance, the work done is negative. Next, let's look at 0 work done. Let's say we have a box, we apply a force, but the object stays at rest. That means the distance covered is 0, so the work done will be equal to 0. That's the first case. Next, think about a person carrying a load on his head and is moving. So the force on the box, which is on his head, the force of gravity is downwards. So if you look at the angle between the force of gravity and the distance covered, that's 90. And if the angle is 90, cosine 90 gives us 0, so the work done will be 0. Another case is when something is moving in circular motion. So the motion, that is the distance, is perpendicular to the force. The force in a circular motion is always towards the center. So the angle here is 90. So again, the work done is equal to 0. Positive work done. Let's say that we have a box. We push the box with a force F, and the box moves a distance d in the direction of the force. That means force and the distance are in the same direction, so work done will be positive.